Good afternoon and welcome to today's webinar titled, Are You Ready to Leave Guesswork Behind in Your Stamping Die Quotes? Presented by Cimatron and hosted by Metal Forming Magazine. My name is Brad Coogan. I'm the editorial director of Metal Forming at the Precision Metal Forming Association, and I'm pleased to serve as your moderator for today's session. Before we get started, just a few notes about today's Zoom meeting. The meeting is being recorded for archiving, and the recorded event will be posted to our website within the next few days. So we'll let everyone know via email when that webinar is available for viewing online and sharing with others at your company. It should be up on the website within the next day or two. Also, all participants in the meeting are in listen-only mode, which means that our speakers and other listeners will not be able to hear any audio from your site during the program. However, you do have the ability to communicate with us throughout the program by submitting any questions and comments you have using the Q&A link. So use that Q&A link located on the bottom of your Zoom screen. You'll also use that after the webinar to ask questions of our presenters. So without further ado, we'll introduce today's webinar, which is a demonstration of Cimatron's DieQuote, die estimating software in action. During our session today, we'll generate 3 or 4 distinct estimates, depending on how much time it takes for progressive and transfer dies, and those estimates will take 10 minutes or less. So we'll learn how the software automates complex calculations and intelligently recommends the optimal number of operations. So it is now my pleasure to welcome today's speakers, David Lindemann, Senior Application Engineer at Cimatron. Jeff Bennett is here to help with Q&A. And we'll kick things off with Cimatron Regional Sales Representative Donald Hahn, who's going to provide just kind of an overall introduction for the meeting. So Donald, go ahead and take it away.
Thank you, Brad. So today we'll be looking at our comprehensive solution for quoting dies. We'll be able to handle both progressive stamping dies and transfer and line dies as well. We'll show you some of the formability analysis tools that we have. During the demo, you'll see how we can handle die operations with forming, restriking, trimming, and punching. And we also have dedicated nesting tools and single-click punch definition, which we'll show. We have some measurement tools for thickness, draft angle, and body integrity. We also can calculate automatically the die sets, plates, components, and stations. We have support for multiple currencies and labor rates. You'll see that it is very fast. And as Brad mentioned, please type in any questions you have. If we don't get to them during the webinar today, we'll answer them individually as we go along. I would like to now kick it off to David Lindemann, who will do the demonstration. Thank you, David.
Yes, thank you, Don. So let's take a look at the software. We'll start by seeing what type of formats we import. And as you'll see, we can take all the standard ACES, SAT, STEP, those type of files, plus some direct translators for CATIA, UG, ProE. So it's very friendly for taking in different types of data. Once we have established what we're reading in, we're going to bring it into our progressive die environment, in this case, since we're going to do a progressive die quote. On the left side, you'll see the history and the operations that we're going through with each step. On the right side, you see the guide, which simply steps us through the quote. So first of all, the part that arrives may not necessarily be in the perfect die tip. We have the tools, though, to establish what that tip should be. And it's a little better than just visually looking at it, to say the least. So other things we might need to check are to understand what my overall sizes are, how much space is this thing going to take up. And here you see it will quickly generate a box for me to get the overall XYZ size. It could be in millimeters, could be in inches. You can work in any of those formats however you wish at whichever time. Another nice tool is to check to make sure that the angles of the part are going to release. So here you see a draft angle analysis tool It's based upon a range of colors and values that you can control. So here you see anything less than 10 degrees is going to show up in a color other than green. If I'm truly at a vertical wall, you'll see the 0. If it's flat, it's 90. And all through, I can check to see at every location if I've got a wall that's going to pull correctly or not. Finally, we also look at the material thickness. You know, if it's going to be something I'm going to make off of a coil, then definitely I want a consistent thickness. And there might be areas too that require another operation, like a coining operation, for example. Here you can see using some tools to quickly measure in any specific area, like with a sphere or a ray, we can get that overall thickness. So the ray simply works normal from whatever point I pick and stops when it hits the other side, whereas sphere looks at the volume between all the faces right there in the nearby area. With this tool comes a nice looking sectioning tool that will likewise display in the same colors and color ranges. So at any time we can cut a quick cross section if we need to explain something to a customer, ask them a question why there's a difference in the thickness, you name it. So lots of quick visualization tools. And you'll see up there on the main menu, save image. So there's a lot of quick shortcuts to getting the information we need. So at this point, we're going to decide if we want to work with the inside or outside. And that's so that we're going to mathematically compute from one side or the other, or down the middle, whatever the formula is set for 1/3 or 2/3 relationship. And now we're going to estimate the blank. So here you see within the library a ton of different materials that are available that already come pre-built for you when it comes to estimating what their blank is going to create. So of course, every material has different properties, so the results are always going to be different depending upon that material. So let's pick one kind of middle of the road here. You can see the system knows it's 2.6 mil thick. And now we'll do a thickness analysis. So we're checking to see the percentages of the material as they may flow. Some areas the material may gather, some areas it may thin. And here we get a good view of exactly what that looks like in terms of the percentage of that material flow. Wherever I bring my cursor, I get the full breakdown if it's safe or not. Another useful tool is the safety zone analysis. If you're from the die world, you can think of this as your FLD curve. So it's going to show you areas that are likely going to split or wrinkle. So some very quick tools to help you understand the formability of that part. So we're going to actually go ahead now and calculate out the blank, and we'll let it take a few seconds to get that outline. So within, just a matter of seconds, you can see how it factors all those things in to get our overall blank. So you would think of this as a one-hit type of application, a one-hit type of blank, rather than a fully developed incremental type of blank. Here we're creating an offset. Maybe we want extra material all the way around, and we want to include that in the piece part price because we're going to come back and trim it up later. So we'd like to see where that trimming operation will take place. In our nesting tool, we can do a 1-row, 2-row. You see how it tries to reduce material usage by interlacing those different nested blanks. You have full control over how far apart you want the different pieces to be, all the while keeping track of your scrap, your net utilization. You see it's also factoring in what the progression should be. Now, if I wanted to, I can get the optimal nesting condition where it has the greatest net utilization, which can be nice, can be useful. At times that optimal condition may not be the best tool though. So here I've got in mind where I want to have the web attached to the part so that I can carry it. And I want to rotate that to that position. So just by flicking through these different up and down arrows, you can see easily we can control where that nesting is going to be. how far apart the different stations are going to be. And maybe we'll round the progression to an easy number here, something easy to remember like 250. So quickly, we've got the nest done. Next, we want to get our overall coil size. So with that, do I want to trim off to the very corners, the very edges of my blank? Or more than likely, if I'm going to have a carrier and web, I need a little extra material there. And you can see how you can manipulate these numbers so that it's either uniform on both sides or different on both sides. With a single carrier on the top, I don't need any on the bottom, so I'll leave just enough to shear off that sharp corner. There I have my overall strip width that I'll be calculating from. Inside the sketcher, we want to get just a rough idea now of what this strip might look like. We don't have to be perfect. We don't have to, pretty it up like we would a full-blown progressive die design, but just kind of getting the estimates of how big the carrier might be or where we might put our webs at. Here I'm envisioning at the end, I'm going to come back and shear off that half round shape. You see, maybe I'll break out 2 punches there and then have a punch here at the bottom that's going to come off of the coil to clean up that edge. And everything is very easily manipulated. You can add dimensions, but you don't need the dimensions. Pretty much the sizes we get are going to come from the geometry itself when we get our calculation for overall steel sizes. Next, we want to have a pilot. Where I put the pilot is really not that important. It's just a matter that I have it. That way I can identify a pilot station, and it will carry the number of pilots down the road with each of the stations that we generate. So to quickly get some punches, we just single pick indicate where those different punches, or in this case the pilot's going to be. Here I have a big punch that's going to take that material out. This one's going to come off the edge. So I've got 2 major punches, my pilots, and we're going to identify what goes on what station. So here's a pilot for my pilot station, and then I've got 1 blanking punch. Here's the second blanking punch. So you see I've got already 3 punch stations. I already know the sizes of the stations. I know that perimeter to understand what it will take to wire EDM those punches, as well as the holes the punches go through and the holder for the punch. Let's do something similar now when we look at the forms. Basically, how many hits do I want to form this? Well, I see the 2 sides that are bent down as separate forms. I might see another form in the middle. So I've just used the paintbrush here and quickly trace across what I want to call, in this case, this flange of form. So I've got my main form done already, and now I'm going to break out each of these individual smaller form areas. So maybe down here in the center, I'm going to bend it down, then bend it back up. And I'd like to, isolate each of those. So just by dropping in the paint and then coming over here to my list, call it a form, I've now got 4 forming stations. And again, it knows how big these stations are because it's taking the measurements right off the part here. All right, here's another one. If I get extra, just retick it. And now I've got another forming station. So very quickly, just by coloring the part up, I'm identifying the type of station, and it's getting its size that it needs, and it's going to be able to calculate the cost of that station. Next, let's pick everything for a restrike. Maybe I'm only concerned with the outer 2 flanges and make sure they're correct, but we'll go ahead and hit everything. Again, you can have a number of different restrikes. Now I'm looking at all the different trimming as well as, typical punch holes. Here I've got some circular holes. I have a non-circular hole. So I have a number of different catalog punches I would use to create those. At this far end, we were looking at cutting it off. So we'll call this a trim edge. And it's basically pick the geometry that we want for that trim edge. And that will be a direct trim. Now, maybe I want to do other things that are going to be a trim. Maybe I want that edge to be on a trim. You have the choice of either making it a direct trim, or it can be a cam trim, where you're going to use a side mechanism to trim that. And that will greatly affect the price, also the tooling price, because you have that station. Finally, we'll take it over to costing, where we say, I've got a single edge carrier, and we'll now generate some prices. So as soon as I see my die quote, it has already calculated the tooling cost. But let's kind of step through and look at it. It's just basically working off the standards that we already have in place. So those standards can be your standards. You'll see how it's calculated the overall blank. It's looking at the different cutting and forming, the wire EDM distance, the number of stations throughout the die. It's calculated everything that we marked up. It knows how many blanking stations and how many trim stations. Maybe in my mind, I'm thinking I really could use one more idle station. So you can easily just go in and change that value, tell it to update. Then what it does is it grays out the top there, like you see with all those top tabs. So it wants you to take a look at everything to make sure it's where you want it to be. Do I want to have nitrogen springs? What type of materials am I using? Well, here in the pull down, I can grab any common steel that I have set up here in the library. And when it grabs that steel, it's of course now going to cost that plate out based upon the steel price that's already set in the system. So I would pick those steels and something that makes sense, obviously. O2, A2, that kind of type of steel. Here you've got your overall lengths of each of the plates, the plate thicknesses. And now we're looking at the press. So you can have a library of press based upon the customers that you're quoting for. If you see something in red, that means it does not meet the specification of that press. So it alarms you to that. There was the overall stack height. Now I'm looking at parts that I want to maybe have, in stock, just so I have those for replacement if I need them. Is there something about this particular die that's different? Well, I can use some parts that aren't typical, that I might not usually quote for a typical die. Like maybe I want to have a chute to gather all the slug drop and kick it off to the side away from the press. You can include those things as well on a non-typical basis. Once we have done that, we looked actually at some of the settings. So it's now going to recalculate where everything gets updated live as we work with it. Under estimate die, the blue is your material, the green is your labor. So here's a full breakdown for all the different plates, here you see the parallels, you see the punched holes, all your stripper plates. We've itemized out the spring pockets, the spools, what is involved with each of the materials, and then of course the labor rate that goes into performing that operation, whatever it may be. Here at the end, you get the final cost breakdown. So about 235,000. Up at the top, you see it was done with United States labor rate. So also no profit. So let's say maybe we want to do it somewhere else. So we'll build the die in Canada and we'll say, oh, give us a 20% profit. We recalculate it through all the areas that are affected by those two factors. Now, as we scroll back down to the bottom, you can see price has changed. All right, so always you can itemize what you want to do with this quote. Is it something that you've been awarded? You want to keep it in process? You can have a way basically of controlling the flow of that quote, keeping track of its history. You can also do a piece part price estimation. So we'll give it a annual usage here. Maybe we'll run in 10 lots throughout the course of the year. Put in my sheet metal cost. So that's something I'd keep track of throughout the year as the sheet metal prices would change. Rate of operation, how many do I think I can get off the press in an hour? rather than say just cycle time, but it cycles per hour. I figure maybe it'll take an hour to take the die in and out. And then what's my press rate? What's my operator rate? How many times do I want to cycle through, create a part, and then come back and say, well, probably should take a look at it, maybe do some maintenance. Well, maybe 50 thousandths is too much. Let's go 5 thousandths. And then with each time I interrupt, what am I going to charge for the maintenance? There's a place you could put a value added cost if you want, and you can amortize your tooling right over your piece part price. Here we just broke it down just to what it would cost to make the part. So a fantastic calculator for putting together a piece part price. Now in our report, we gather all that information together. Here you see every bit of it ready to be sent out to a report. And when we send it out to report, it's going to be an Excel format. So from there, you can customize it to whatever your needs are. Maybe you've got different Excel spreadsheets or templates that you use for different customers. Right? You see a summary, an overall cost breakdown, your die specs, and your charts. And you notice on the first one, the summary, again, you can drop pictures in at any time. Just hit the picture button. Now you can pop it into your report anytime you want to. So that's like a very fast overview with a breakdown of everything that we could talk about as quickly as we could here. Let's just run one through here again. So we'll do another progressive die with a different part. This one's going to be quite a bit bigger. And looking at this part, you can see it's got some big flanges on both sides. It's a lot of forming going on there right in the middle of it. So maybe we envision it to be a 2-out. Well, it gave us an interesting message there when we went to skin it, said you got extra material in here. And you can see that this part came with the nuts already attached to it. So instead of us worrying about removing that geometry, we'll let it do it for us. It knows what the sheet metal is that we're attacking. That's what we're going to build on. As before, it breaks it out into those 4 operation zones where we can identify what we want to do with each. Here we go right to the blank. Again, the thickness has been established. The material properties have already been established once we pick the material. So it knows how it's going to go about unfolding it. Okay, much as again, it's a crash form, which is pretty sufficient usually for a quote. Again, the strain analysis, we can check for the formability, make sure we're not getting into anything too terribly deep that's beyond us. I might worry about some of the wrinkling that I see. So that might tell me that I might want to stretch that material a bit. So do I do something else like form it twice, or do I add more material around it? If I were doing a transfer die, would I want to maybe put a draw bead in? The blank will allow you to do just that. You can also include draw beads as well as blank holders and pressure pads. Like before, we're setting up the nesting. As I pull my progression wider apart, I can see the actual distance left in between. That's going to give me an idea of just how thin that one little punch is going to get. In this case, maybe we're thinking we'll have a carrier on the top and a carrier on the bottom. All right, so give myself a little more material to work with. And like before, we want to create as simple a sketch as we can. Now, I had someone ask me, I do pretty much the same type of carriers and webs. Can I just keep doing that and save that sketch and use it again and again? Yes, you can. We do allow for that, so you can save your sketch and just drop it in. You might look at this part and say, well, I'd kind of like an expandable web, at least on one of those ends. Well, that'd be the time. Create it once, save it, now just drop it in. Another way of handling that is, again, you're just looking for the cost of it. It would be to add another punch station and include the cost for the punch that it would take to make the expandable web. So I'm letting the constraints of the sketcher show me when I'm lined up, parallel, perpendicular, and maybe just a few dimensions here, just so that I know I've got the balance that I want. So you can see just a couple picks, snap the dimension in, and I'm good. I'm really only concerned about that punch area that's between the two blanks. Do I have to be perfect on those corners? No, I'm just, getting the essence of what I need to do with 3 punches to create that part. Again, I'd like to create a pilot. So we'll simply just snap in a pilot. I'm not even worried about lining it up perfectly. I'm not designing here. I'm quoting. Right? So now we can go about and establish how big these punches are and what the size is and what the cost will be then. So single pick those areas again. There's my 3 punches. And then with the 2 pilot holes, we'll pick both of those. We'll tell the system they are uniquely the pilot. So that's going to be the shape repeated. That's where my pilot's going to go. So I have a station for those. Maybe the 2 end punches I'll keep together in the same station, but that big middle one, we'll put that out there as a separate punch. On to forming. Well, I'm probably going to form the majority of it, as much as I can anyway, with the first hit. But then I need to address what to do on these outside flanges. So we'll go ahead and pick these. Now by picking that and putting it on a different, you almost call it like a set or a layer, you see it will deduct it from the first forming station and include it in the second forming station. Likewise, we'll do the same on this side. Maybe I want to include these as 2 separate forms. That way I can use forming punches to come down in between where the blank would be, basically. So one punch would do each side at one time. Okay, that looks good. Again, it's generating all the information for me that I need in the background. Let's do a restrike on everything, as opposed to making maybe 2 separate restrikes for each of those flanges. And now let's take a look at what we're going to do for piercing. Well, here I've got these side holes, and I could elect to make them straight holes that I would do while the blank is flat, or in this case, maybe we're concerned about the accuracy, so we'll do them on a cam. Same here on the opposite side. So we'll have 2 separate cam stations, 2 separate trimming stations. Looking down the center of the part, I've got those nice, easy round holes, so I'm just going to drag my paintbrush across those, gather that information. And then we've got these rectangular holes. Try to pick my edges as clean as I can. Looks like I missed a piece right back there. And then one more up here. That's good. So it identifies those areas for me. And I can have separate costing for all of that. Down here on the ends, those I'm going to trim up. Also, I'm going to trim these up. And then it looks like, again, I need to get a little closer on the right-hand side. So we'll just pick back through that again. So it's pretty straightforward and easy to pick these things. And those things we want to use as a direct trim. So depending on how concerned I am about those outer edges, do I want to retrim them or not? I know I want to trim on the ends, but it becomes just a matter of understanding what the needs of the part are. With that, we'll do a double carrier, one top, one bottom. We'll take it to the estimation part of our software, which is up on the cloud. Might say that no important data, confidential data, is going to the cloud. It's just the information, the math. Scrolling through, maybe I just want to do a couple changes. Again, we'll do something simple like maybe change the idles. All right, that's going to change my overall total stations. Maybe I want to include another punch station because I'm concerned about making a webbing. Answer the die specification. Yeah, I want my 2D, 3D drawings, all that. Go ahead and recalculate it now because of the new stations. No custom items for now. Under die estimate, again, we look at the material. We'll look at the labor rate. So here, just to get the cost of it in US dollars, I leave it as it is. But now I'm thinking, well, let's actually make it in Mexico with 20% profit. And I will recalculate everything. So again, scrolling all the way back down to the bottom. Now I see what that bottom line number is. All right. Plus the delivery time, total amount spent in order to create this die. So that quickly we've gotten to the bottom line number, which is what I want to show you. So if you're kind of in your head keeping track of the time that it takes, you get an idea what it's like to actually work with it. Let's do a transfer die. All right, so very much the same as before. We'll pick our part. Your choice to work in inches or millimeters. Same wizard as before. Now here you can see what the part looks like. We want to pull our die direction up along the Z-axis here. And let's just start stepping through it. So when I hit the die skin calculation, it not only grabs either the punch side or the die side, but you've been seeing how it lays out these 4 zones. One will be for forming, one will be for restriking, one will be for the blank. Again, pick my material. And with that, we know we got it. Go ahead and calculate it. This will give us very quickly the overall blank size. And you can see we're letting it run pretty much real time down there at the bottom. Okay, so there's my blank size. Flip that around so you can see it's not quite a perfect circle. Here with our our transfer dies, we can now look at what type of steel shape we want to work with. All right, is it a rectangular sheet steel? Maybe we'll generate a parallelogram shape. And you can see, of course, with round shapes are going to be very similar, but it can mathematically generate these different shapes depending upon, what's best, including a chevron here. Rectangular is perfect. It's because we're, sticking to the rules of the minimum amount of material. Give ourselves maybe 5 millimeter in between. And then do I want to have something on the top and the bottom to cut off? Sure. All right, so there we've got our sheet steel. And there we just progress onward. All right. Next thing we'll do is we'll pick our forming. We'll do this pretty straightforward. Pretty much this whole thing can be made with one forming die. So we'll throw that all under forming. Next, we'll do a restrike. Perhaps again, I'm thinking, I'd like my flats to be really flat, but one restrike ought to be sufficient to get that done. Finally, I'm looking at my trims, also the punch holes that I'm going to create. See how it goes through, and if it's a true round, it will identify that for you. And already that true round is placed inside my circular hole listing. Grab those remainders. Maybe I'm forcing it to be a circular hole, right? Now we'll go through and scribble my way around this looping center hole, which goes up and down. See, it's got a couple of different heights to it. Finally, we'll look at the overall trimming. All right, that would be a big operation. We'll pick all the outside perimeter. And just like that. Okay, so we've gathered the information we need. We'll take this over to our estimation. No carrier. And then from here we can see what the die lineup will be. We already know it's basically going to be the typical four transfer dies that we would need. And you can see die type, it says transfer. And here we'll go right to the bottom line. Again, we'll pick where we want it made, pick our profit, have it calculate. And now if we go right to the bottom, you can see what that die lineup would be, what the cost would be. Right. So very quick, very fast. We know that most people quoting dies are quoting them by the thousands, and they're typically getting maybe 2-3%. So there's a lot of quoting going on, and to be able to do it quickly is just a huge issue. One more, let's just take a look at something with some straight linear bends. So you can see it's pretty straightforward when we run this through. Same process. Pick the part, bring it into our quoting software. This is a simple little bracket. As you can see, it's got mostly 90-degree bends on it. Fairly long though, so we might have to have, 2 carriers, even maybe a little bit of an expanded carrier, since we got a little bit of a fold going on each of the ends. I'm just going to step through and let it happen, right? There's my die set. There's my die skin. There it's creating all the different areas where I'm going to define each of the stations. And here I pick my material. Maybe we'll break it up and do something different here. Maybe pull in a stainless, let's say. Again, all the factors I need are already loaded for me. Now it goes out and establishes what that blank is going to look like. There's the blank. Next, we'll start to lay out our nesting. How much distance do I want to have in between these different blanks? I'm always, again, looking at my net utilization. Do I want to see what it looks like optimized, where it's like the absolute best net utilization? Interesting how it picks those things on an angle for me, but I'm up to 62% utilization. So it's the trade-off then between the best use of the material and what helps it make it the most toolable. Got my progression. Maybe for kicks, I look at a 1 out or 2 out, just to kind of feel what it would look like. Rotate it around, change the horizontal and vertical shift. That way I'm just kind of nudging it along to see what it looks like if I get further and further away. All the tools are there. We'll keep it simple, just a 1 out die. Now we're going to set up what our coil width would be. So again, we're going to need room to have a carrier, top and bottom. That looks good. Quick little sketch to establish a carrier. And pretty much all that's going to be is just 2 simple rectangles. Let's zoom up here on the end and just have a couple points we can attach the web to. In this case, I'm not even really going to worry too much about my dimensions. So right there's my endpoint. Now you've noticed you've got a part filter. That way you can isolate, say, I only want to see endpoints. I don't need to pick anything else. That makes it a bit easier to zip right. So just a quick representation of what this is going to be, because as you can tell, pretty much what I'm the most interested in is getting the factors involved for those punches. I want to get the perimeter of the punch, the size of the punch. Once I know the coil width, I'm pretty well established as far as the coil goes. Couple more quick references. And then a quick sketch. Again, I'm not worried about trimming everything up. Like I need to have an absolute perfect, wonderful drawing. It's going to be as dirty and as quick as I need it to be. So let's break that off as a separate punch. Maybe do the same up here at the other end. You know, look back on this, I think, well, maybe I'd also go back and make those end punches something different. Let's definitely break that in the middle so it's not so big. There I've got my punch configuration. So if down the road I change my mind about things, all I have to do is come back and make a change to it. There's my pilots. And then we'll grab these 4 punches. Simple singular pick. Okay, now let's assign them where we want them to go on our lineup over here on the left-hand side. I want to make sure I get a good pick on those pilots. And then just a click and there they go. So when I look at this now, I'm thinking of staggering it. I could probably do all these punches in 2 stations and just make sure I've got enough distance in between. All right, so I've got 1 pilot station and 2 punch stations, each with 2 punches on them. Again, here I want to find out, looking at the part, you know, how I'm going to go about making all these different forms. So let's say we're going to have our flat first, and then we'll put that bend in on both of those ends. So I'm just going to single pick my way around that, since that appears to be the easiest way to do it. All right, and then we'll attach those to our forming. In this case, separate form. Now we'll go through and pick this rib area. Actually, I picked an extra one, so by picking again, I can unpick it. All right, we'll call that a rib. And you saw it there on the list, all the different die features you can pick. Again, on the other end. There we go. And all that's left now is going to be those 2 large side flanges. So we'll do each of those separately. And again, our paintbrush comes in handy just to roll right down along that, picking all those faces in one continuous motion. Here I'm putting it in as forming. In this case, I could put it in as bending or forming, whatever the case may be. Okay, so now we've got everything picked for our forming stations. We'll go back and do a restrike. Okay, I'm just worried about restriking those outside 2 bends. And now I've got all these little holes to cut. So again, do I want to do those side holes when they're flat? Do I want to do them in a cam? It's just whatever I call them is how it's going to be handled by the system. So let's grab these rectangles right through here. Those will all be punches. So they're going to be a non-circular punch. And then we've got our 3 holes on this side. Call those a circular hole, and our 4 holes on the opposite side. So with that straight linear bend, it should be no problem just to bend that over, and those holes should stay nice and round, right? So that one is pretty much colored up the way we need it. We'll take that over to our estimator. That's going to be a double-edged carrier. Runs through all the stuff that it needs to run through on the cloud. And if I want, I could go right to the bottom line, or I can take again a look at, what my different stations are and just kind of change these as I go. So total stations, we estimated at 9. I'm suggesting a couple more idle stations. Hit the update button, step across all these different factors until, I've got what I want. Again, you see all the defaults that it will automatically select for me. The materials for the different plates, the different plate sizes, anything in particular that I want to add to it. And then here's the estimation breakdown: material, labor. Okay, this time, let's go ahead and send this one to Mexico. 30% profit. Generate it. And then when that's done, my bottom line number will be the cost for that die. So that took maybe 5-6 minutes. It wasn't that long. So you get a good idea of what it's like to work with. Hopefully we explained it well enough that you can see the thought process behind it, and then realize once you've done it a couple times, it becomes pretty automatic, and that there's a lot to it that it's doing for you. There are a lot of calculations that it can make to help you reduce the time it takes to generate these quotes. So that's pretty much it for me. I guess we hand it back over to Brad.
Yes, sir. Thanks so much, David. Really nice demonstrations. Got all 4 of them in there. Nice variety. So we do have a few questions from the audience, and we've got about 10 minutes or so. So if you've got questions for David or Don, or for Jeff Bennett, who's also on, go ahead and post them in the Q&A panel on the bottom of your Zoom screen. David, and maybe Jeff as well, the question comes from the audience about tryout time. How do you accommodate tryout time in the quotes?
There is an area in there where you can set up like inspection. So you say, I want to try this many pieces. I'm going to, measure them. All that is going to be part of that cost that goes into the tooling price. Plus, if you want to, drill deeper down into that, that can be a non-standard item if it's something that you don't do all the time. And you can just list that as a labor rate, a labor cost that you would add in addition to everything else. There's a setup time that's involved. That's got its individual itemization. There's a maintenance time. So there's, the breakdown is there depending upon where you want to put it.
Can you hear me okay? This is Jeff Bennett. Yeah.
Yep.
In addition, one of the settings, which you really didn't get into the settings much, but the settings will allow you to set factors based on difficulty. So difficulty can be based on anything. It can be based on material type of die. You can use simple settings like easy, average, difficult, and then it will give you an initial estimate of the die development time based on a percentage of the standard hours that are required to build the die. So it adds that on. And then in the final estimate, if you feel like those hours are not enough or too high, you can edit those before you rebuild the estimate.
Great. All right. Thanks, Jeff. Thanks, David. What about 4-slide tooling? Can you use this for 4-slide or no?
I can answer that. It has been used for that. what you do is typically remove everything that's die related, such as the die shoe buildup, those type of things. And then it calculates the cost based on just the forming punches and setup and that kind of thing. It's not designed for multi-slide, but it has been used for that successfully.
Excellent. Okay.
Mhm.
Can tolerances for the part be included in the quote? I assume they can.
Yeah. I mean, you're talking about perhaps having a little more tryout time to make sure you're hitting that. All right. So there would be a factor involved again, just like what Jeff was saying before. That would probably make it a more difficult die since you're trying to hit the tolerances and may require some more work on it. But it would be like that basically.
Tolerances also usually indicate if they're tighter, you may require additional stations or additional punching or restriking or trimming or those type of things, which adds to the cost of the tool.
Sure.
Mm-hmm.
Okay. David, you mentioned that the calculations, if I heard you right, are actually being done in the cloud. What about the results? Those are, I assume those are not in the cloud?
The results, like as in the final quote cost, those are there. There's with
Okay.
that quote, but basically when you create your report, you're creating what you need then to bring it back down into the real world, I guess. The CAD data, everything, it stays on your laptop, your computer. All right. What
Okay.
we send to the cloud are the factors we need in order to make those calculations.
I got you.
That's it.
Yeah, no product data is stored on the cloud, and the estimate is not retained in the cloud. There is, if it's okay for me to say this, David, the plan is to give users the ability to opt in at some point if they do want to store into the cloud. Currently, though, it is not.
Gotcha. Okay. Can a software quote tools with greater than 2 parts produced per stroke, so multi-part out?
Yeah, you can make that happen. As you can see, though, like when we did the nesting, it really was kind of designed with 2 rows in mind, but there have been times where we've done four rows across and
Okay.
more. It's it takes a little bit more work, but it's very doable.
Okay. Can you talk a little bit about what the implementation process looks like for getting the
Yeah.
software up and running?
Yeah, exactly. That is a good question because you might look at the numbers I had and say, oh, I never would have quoted it that way, or that doesn't look like the number I would come up with. But what we do is we'll take a series of your quotes, maybe a good sample size of 12, 15, and we'll match the system to your quotes. That way we get all the settings and all the factors right. And we basically tune it to what you're doing. And then from there, it should be just a matter of you adding what other details you may want for each individual die.
It comes with the initial settings already done based on industry average values, but typically the user will want to modify those standards to more closely fit their actual cost.
I gotcha.
Right. And when the person is thinking about, buying steel or buying the coil, those costs are going to have to come from the market as what they are for that day. So there's going to be the constant maintenance of checking to make sure that you've got the most up-to-date steel costs in there because, things keep changing so much for so many people that it's something they have to stay on top of.
Yeah. So the customers can add their own materials to the library, the material database.
Yes. Not just the plate steels. We're talking about like the forming steels. So if you have a material, maybe you're working off material cards and you have to follow those, you can input those properties and then you can look at the simulation and create the blanking just like we showed in the demo today.
Gotcha.
the system is highly configurable. In materials and in labor. So there really wasn't time today to get into the settings of the system, but there's extensive configurability.
Okay. How does the software integrate then with die design software? And I believe Cimatron has its own die design software, right? So do they integrate?
Yeah, you can. I mean, you can certainly open up the files across the two softwares. It's the same database, you know, the same software. A lot of the tools that you saw in DieQuote are coming from the development that we did for a full-blown die design package. So there's more that really DieQuote can fall back on in terms of if it needs more functionality in the future. Okay, and we're always updating, you know, what these different die functions are is based upon what our customer needs are. So that'd be the best integration. Otherwise, you're bringing in, you know, you're going to be bringing in a piece part, and from there, that's what DieQuote is going to need. So it doesn't need a full-blown assembly from another die system. It just basically needs the piece part to generate the quote for you.
Okay, so then the follow-up is, can you quote with just the skin of the part,
Yeah.
one side of the material? Yeah.
Yeah, you sure can. Yeah, a lot of automotive guys are going to get just the one skin to work with. So, yep.
We do have a couple more minutes if anybody else has some more questions for these guys. If there's a change in how I want to quote the part, do I start over? Can I adjust the quote to quote it in maybe a couple different ways?
Right. So like for instance, maybe like we saw when I was coloring up the faces to make a certain forming condition, you know, instead of making it two different forms, maybe I want one form. So I would just go back and make those two the same color. So now I've just eliminated a forming station. Well, all I do now is go back to the estimate button and it'll, you know, generate the numbers based upon that new selection. So really it's just that easy. And if I were to say, oh, these punches are terrible, I need to break them up more, you know, I can go back, divide up my punches, set them on another station. It'll add that station automatically and then regenerate the cost for me when I again hit the estimate button.
Gotcha. All right. Looks like there are no more questions for you guys. So I think we'll go ahead and wrap things up. Thank you, David, for the demo, and Don and Jeff as well. Thank you for really an outstanding, well-rounded presentation. Demonstrations are always great. So thank you for those. To the audience, thank you for attending the program today. We hope everyone found it to be a valuable experience. Once again, an archive of the program will be available on our website within the next day or two. When it's ready, you'll receive an email from us so you can review it again, maybe share it with some others within the company. So you can go ahead and close your browsers now. Thanks again to our presenters today from Cimatron. I wish everyone a great afternoon.
Thank you.
Thank you.